Hi General Math students, we're going to discuss depreciation in this example. It's quite a big example, so get set and get ready to do some calculations. Now, there are two methods for depreciation, and the idea of depreciation is that if some equipment, say like some computer equipment or maybe a car, a fleet of cars for a business or something like that, when they're bought, they generally go down in value as time goes along. So they have wear and tear, technological advances occur, and the equipment loses value over time. So that can actually be claimed against income tax or business tax, and that can be used to deduct the amount of tax that a company pays. So the first method is straight line depreciation. There's the equation for it there. This says that the value of the asset is equal to negative D, which is the depreciation amount per year, how much it goes down in value each year, multiplied by the number of years plus the original cost price when new. The other method is reducing balance depreciation. It looks a bit like the compound interest formula, but there's a minus in between there rather than a plus. Now, this says that the book value after a certain number of years of depreciation is equal to the original cost. Bracket 1, take the annual rate of depreciation as a decimal to the power of the number of years of depreciation. So it's very similar to compound interest, except it's going to go down in value, not up in value. Now we're going to go straight into a big example here where I can demonstrate both straight line and reducing balance depreciation equations in one video. So, computer equipment worth $3,000. We're going to first depreciate this by the straight line method. Okay, and so that would involve a formula that looks like this, where the value is equal to negative D, the depreciation, times N plus the original cost. So V and N are going to stay as is, but we need to find numbers to replace D and C in the equation. So V equals negative, 15% of the purchase price. So that's 15% of $3,000, 0.15 times 3,000. So if you check that, you should find that that's $450. So the value of the equipment goes down by $450 each year under this method, plus the original cost. That's where the C value, that was $3,000 originally. So that is the formula that we will use here. And they want us to tell them how much is the equipment worth after 6 years. Okay, so we're going to put a 6 where the N goes. V equals negative 450 by 6 plus $3,000. Okay, so you might want to pause the video and try putting that into your calculator to see what you get for the value of the equipment after 6 years. And what you should find is that it's worth $300. So it's gone from being worth $3,000 up here to $300 at the very end here after 6 years. Now, if you really want to, you can go and fill in this table. Okay, I'll show you what to do. We have the amount of depreciation here. Now, that's going to be the same right through here. That doesn't change. So I'll fill all those in, right? Now, after 1 year, that's the total amount of depreciation. That's our accumulated depreciation. So we take that off the $3,000 and we get $2,550. That's what it's worth now. So that carries over to the start of the next year, and we take another $450 off, which is a total of $900 off that. So we take that off again and we're down to $2,100 and so forth. So you should count that down and fill this in, and you should get $300 at the end. All right, now I'm going to show you a table in a moment, and that's going to show you what you should get for your answer there. Okay, so you can check your table against the one I got using an Excel spreadsheet. Okay, so if you want to pause the video now and try and fill in this table, go ahead and do that, and then I'll show you that answer later on. Okay, if we were using reducing balance, well, the formula looks like this, where A equals P times 1 take I to the N. So in this case, our rate of depreciation, 25%. Okay, so the amount that it's worth is, we put where the P goes, that's the original cost of the equipment, $3,000, bracket 1 take 0.25 to the power of N. And we could put any N value in here, and we'll find the value of the equipment after that many years. So here, this is N after 6 years, so N equals 6 years. So we're going to put that in for that N value there. And if you put that into the calculator, you should get that the equipment will be worth $533.94. So that number should be right down the bottom here for that final value there. So under this method, it starts out being worth $3,000, and after 6 years, it's worth $533.94. So for this one, how to work out the depreciation year upon year. So that's the changes in this one from year to year. In the first year, we take 25% off 3,000. Okay, so 0.25 times 3,000. So that is $750 gets taken off. That's the total at this point in time. So if we take that off the 3,000, we get 2,250. So that carries over to the start of the next year. And now this year, we're going to find 25% of 2,250, which is $562.50. You can check that calculation. So that adds on to that, and so far those two added together give $1,312.50. So now the equipment's worth $1,687.50. So that will carry over, and so forth. So now you could work down through that one and see if you can get that same number at the end there if you want to. What you'll find is that because of rounding along the way, your answer might say 93 at the end, just from rounding off these numbers along the way, but close enough. We get the idea. Okay, so I'll show you these tables now. That's what you should have for each of those if you want to do it on your own. Okay, so you could go and try it and see if you can get all the correct numbers and then compare it to these two. But that is the value year upon year. So you notice for the straight line method, our depreciation amount is $450 each year. For reducing balance, it starts out more, $750, but by the last year, it's only $177.98. So reducing balance, get it going lower. Right. So what else do they want us to tell them? Oh, they want a graph showing the value of the equipment using either method. Righto. So the straight line method starts out at $3,000, and after 6 years it's worth $300. So I'm going to mark those two on here, right there. Okay, and I'm going to join those up with a line. Just the straight line method makes a straight line. Okay, so I'll join those two up. I can even continue it on a bit if I like. Just get them to go through properly. Make it a bit thicker. There we go, that looks good. So there's the straight line method. Now with that one, you only need to plot the very start and end points here. Here we are at 0 and 3,000. And over here, after 6 years, the equipment's worth $300. Those are those two coordinate points. Now, reducing balance is not going to be quite as simple as that. We're going to need to plot each of these values from along the way. Yeah. So, talking about these ones here. So I might just copy them and see if I can bring them in over here. That'll do. I can see what those numbers are now. Okay, so the reducing balance, I'll go in red. Now that started at the same amount at 0 years, it was worth $3,000. After 1 year, it's 2250, so 2,250. It should be right there. Okay. After 2 years, 1,687.50. So close to 1,700, about say there. 3 years, we're at 1,265. So 1,200, about there, close enough. You can see it'll start to curl back up towards the straight line method and catch up with it shortly. 950 is right there. 711. So here we are at 600, 7. It's pretty close now. What's that, 700? Oh, I'll just put it pretty much on the line. They're pretty much intersecting at that point. They're very close to anyway. And then by the last one, 533, it's actually up above it, about there. Okay, so that's at year 6. So for 6 and 533.94, I'll just mark in that coordinate point as well for that last one. It's always good to put some coordinate points in, and I'll put the first one, 0 and 3,000, up there. Now what we want to do is put a curve through all of those. That'll do. And we can see that a point of intersection occurs right about here. Okay, they cross over. So that's the important thing for us, is that point of intersection. Just after 5 years, the two methods are worth the same amount. So use a calculator to find the intersection point of the two graphs. Okay, so that's what the next bit's all about. So a couple of ways we could do this. I can just go into here and I can go add calculator and menu, algebra, solve, and I'll put in the two equations that I got. So I had negative 450, instead of n years, I'm just going to use the letter x, plus 3,000, okay, and that I'm going to make that equal to the reducing balance method. And by the way, I'm only using the right-hand side of each of the two equations. So if you look carefully back at those equations, you should be able to see what I'm doing here. Okay, it might be a little confusing to you, but and here we're going to put power x. So instead of using n's on the calculator, we use x's. Now the calculator is pretty smart, but it's not smart enough to know that we wanted to solve for that x value, the number of years. Okay, so we'll enter that, and we're told that x is at 0 and 5.15. Those are the two intersection points. So to make sense of this, if you look back here, there's a point of intersection on our graph at the start at 0. But that's not really the one we're interested in. It's this one here at 5.15. Okay. So the calculator found that for us. It wants the intersection point. That's important.
intersection point. So we know that it's x is